Hi, I'm Sasha. I'm a senior software engineer at LinkedIn working on machine learning infrastructure. I like cappuccino in the morning and espresso in the afternoon, and I roast my own beans.
I'm Rupesh Gupta. I am a senior staff engineer at LinkedIn. I work on the search and recommender systems at LinkedIn, and I like my coffee with milk.
So, welcome back to another MLOps community podcast. I'm your host, Demetrius, and today I am with none other than the incredible Skylar. And we were just talking about tiny houses because, Skylar, you're living in a tiny house these days, man.
Yeah, it's awesome. It's amazing. I think I'm going to do more of it.
And everyone is probably thinking, I thought we just tuned into the MLOps community podcast, not a tiny home one, but we wanted to chit chat about a little tiny house before we jump into the greatest LinkedIn podcast ever. I ended up talking for like another hour with our guests after you left, Skylar. You bailed early.
Wow.
And then I got all the information on how the newsfeed works and how to kill the algorithm and get all the followers that I need. But that is something that is only privy to myself, and I cannot share that with you right now. Anyway, do you have any key takeaways from this chat that we just had?
Yeah, I really loved, how much they focused on making it easy to add real-time features. I think like talking about real-time has been really kind of in the zeitgeist of machine learning recently. I think starting from Chip's great post, machine learning is going real time. You're not ready. And she's right. Like no one is really ready. And like part of the problem is like most of the time, real time features are going to be helpful, but it's so hard to get real time features that just nobody does them. So it's really cool to hear about how Sasha had kind of like worked through that.
Dude, that's crazy that you're saying that to me because I look at you as one of the people that is skeptical of real time and its uses and using it all over the place. Am I mistaken in that view?
I'm a skeptic on most things, and I think I think it's part of the problem is that like real time features take a lot of effort, and so you can toil away to get real time features added in. And probably all the time you spent doing that was time you didn't spend like getting the low hanging fruit. I just think most of the time there's like a lot more low hanging fruit. Getting to real time probably is like a level of maturity in machine learning that most people aren't at. But hey, I think if there's somebody that builds some infrastructure that just makes this dumb, simple, easy, and you don't have to think about the real time nature of it and you can just do it, make everything real time. Do it.
Oh my God, I never thought I was going to hear that from you, man. It's like you've changed sides. What is this? Somebody paid you off in the background. Something happened.
It must have been Sasha,
Yeah.
Just seeing him smile again and switch sides.
And for people that do not know, you were working with Sasha back in the day at LinkedIn. So this is a nice little reunion that you had. And for me, I really enjoyed when they were talking about how, as you're looking at the news feed of LinkedIn, they're trying to balance out what you're looking for and what you're engaged in now versus that long-term engagement. And so that was a nice little problem that they got into. And if you look at your news feed, you do notice that sometimes their news feeds have things like, oh, this person liked whatever, or here's an event, or here's an update from a company. And there's so many different ways that you can interact with LinkedIn. And then on top of that, layer in job posts. And so if you like job posts, or if you're seen to be liking job posts, there is that problem of, are you liking the job post because you're looking for a job? Is it because you just want to amplify it because you know the person that is trying to hire? Or are you just into hearing about job posts all the time? So with that, I thought it was fascinating to counter the two, the idea of your short-term wants and those long-term wants.
Mm-hmm. Yeah. It's a super hard problem to solve. Yeah. So very interesting to dive into the details around that.
So while you're in your little tiny house and I'm in Europe, so basically in a tiny house, because as we said, everything is smaller here compared to the US, even the roads. I mean, it's a whole different ballgame, man. When I was here, I was telling you, I got really into just the little tiny house tangent before we jump into the actual conversation. I got really into the idea of how to maximize the space and every square inch of your house and how you can set up different things. And so I converted, when I was living in Spain, we had a dishwasher and we converted that into a storage place because we never used the dishwasher. So instead of having this dishwasher take up space in the apartment rental, we made it into a storage unit. And those are the things you got to do. I see a microwave behind you, and I'm super surprised that you have a microwave in a tiny house because I feel like that's something.
This has a full kitchen, like
they did
stove,
not skip
like
on the
everything.
tiny house, huh?
Yeah, it is tiny, but it is powerful.
And I imagine anybody else that is into the tiny house movement knows the guy that owns this house that Skylar is in right now. He's kind of famous on YouTube. So that's a funny one that we found out. Anyway, let's get into this conversation with the LinkedIn crew. And if anyone out there wants to join us in the MLOps community, we're doing all kinds of cool stuff. We got done with a hackathon recently. We've also got lots of newsletters. We've got so much going on. In real life meetup. Skylar, you're doing in real life stuff in LA, right?
Yep. Yeah, come join us out in LA. Even though you'll probably have to drive an hour to meet us.
Living in the same city. Yeah, and if you enjoy this podcast, it would mean the world to us if you shared it with one friend that you think would also enjoy this. Without further ado, let's jump into the conversation. So, I don't even, you know where I want to start? I mean, this is a LinkedIn reunion. Skylar's here. Rupesh, you and Sasha both used to work with Skylar. What's changed since he is not at LinkedIn, for the better or worse, whatever you want to go with?
Well, so if I remember the meeting Skylar and I had, like a few feet from where I sit, that was like in a different life in a sense that was before COVID. Mm-hmm. Right, and that's that kind of changed and that impacted our life. But it is slowly getting back to normal. You see more and more people on campus. Skylar, when you are in the Bay Area, feel free to jump for lunch and see for yourself.
Yeah, that'd be great.
And on the organizational side, I know you guys released Feather, and we were laughing about that before we hit record. That probably would have made Skylar's life a little bit easier. Anything else that happened since he's been gone?
So what we're going to talk about, the whole real-time features, FedEx real-time, would have definitely made Skylar's life better. So we'll...
so you waited till he was gone,
and there's more coming. If you so we're working on I'll use a bit of a slang here, like post quasar world right now. So okay, so
that sounds very attractive to me.
Yeah, so that probably could be topic for another conversation.
Yeah. Well, let's talk about this real time stuff because. This is one thing that I got a little beef with LinkedIn. When I try and tag people, it has a really hard time recommending who I should be tagging, even though I'm replying to a LinkedIn comment and I'm trying to add the person who wrote the post, but then it doesn't automatically pop up with that person, even though I write their whole name. What's going on? Why is it so hard? What are you guys dealing with behind the scenes that I don't understand?
I guess Rupesh would know all about it.
Yeah, so let me just first set some context. So these days, as you might know, there is a lot of information that is floating around on the internet. And most of us have been relying on search and recommender systems to sift through all this information and present the most relevant information to us. And this is one of the types of information that you just mentioned. And now, in order to serve the most relevant information to a user, these recommender systems typically need to know the intent and preference of that user. And usually, no one is going to explicitly state their intent and preference. And the recommender system would need to infer the intent and preference of the user based on the actions that the user has performed in the recent past. For example, if I apply for web developer jobs in San Francisco, then I'm probably intending to find a job. And my preference is web developer positions in San Francisco. So intent is what I'm trying to accomplish, and my preference is the preferred way of accomplishing that intent. Now, traditionally, there is a delay between when a user takes an action and when it can be leveraged to adapt recommendations for that user. And this is because user activity is typically processed periodically into features in a batch environment and then made available to recommender systems. So depending on the frequency of these batch jobs, there can be a delay of anywhere between a few hours to even days between when a member takes an action and when that action can be leveraged in recommender systems. So the outcome of this is that a recommender system might not be able to serve the most relevant recommendations to you based on your current intent and preferences. So, for example, let's say that in the past I've always applied for web developer jobs in San Francisco. But today I might start searching for jobs in New York. And this
or in LA.
Sorry?
Or in LA.
Oh, yes. And this can reflect a change in my preference. But until this change is detected by the recommender systems, I might not see the most relevant recommendations. For example, a content recommender might still continue to recommend me content about, say, web developer job market in San Francisco instead of New York. So the ultimate goal is to reduce the delay between when the user takes an action and when it can be leveraged in the recommender systems to adapt recommendations. And we know that if this delay is small, then the recommendations for the user can actually be adapted in real time.
So I want to preface something. Sasha's been looking at your LinkedIn. Skylar, are you looking for a job in LA? He knows what's going on behind the scenes. Skylar hasn't even told anybody, and Sasha's like, "Oh, you're looking for a job like in LA." But one thing I realized is that I may have come out a little hot on you, Rupesh. I did not properly state that I am a power user and lover of LinkedIn and have been for the last 3 years. So anybody that doesn't know would think that I am trying to take some shots at you. I just love LinkedIn so much, and I see where there's those little tweaks that I sometimes am like, why doesn't this work like I wish it would? But I know Skylar wanted to jump in with something too.
Yeah, now that you drop that in, I'm sure PR is going to approve this, Demetrius. But
I think feedback is most valuable from users with experience. So it's super valuable to feedback from people. Yeah, sorry, go on, Scott.
Yeah. But Rupesh, you gave a lot of great information about how more recent information can be useful sort of in models. But something I'm very interested in diving into a little bit more detail around is how do you actually, what is the technical details behind how you actually get that more recent information integrated into these models?
Yeah, so there are several ways of doing this, but the most common approach is to compute features from the recent actions of a user and then use these features in a machine learned model. And there can be several ways, again, for computing features from recent actions of a user. But the most common approach is to summarize the information that is contained within these actions that a user has taken in the past into a number or a vector of numbers. So a number could be like a float or a double feature, and a vector of numbers could be an embedding type of features. So to give you a more concrete example, let's say we look at all the job apply actions that are performed by a user in the past 24 hours. And then we can get the embedding, which is a vector that represents a job for each of these jobs that the user has applied to, and then just compute an average of all the embeddings that we have obtained for these jobs. And this feature, which is a vector of numbers, is nothing but a representation of the kind of jobs that this user has preferred in the last 24 hours. And as another example, a feature could be as simple as the number of times this user has applied to jobs in San Francisco in the last 24 hours, or the number of times this user has applied to jobs in New York in the last 24 hours. And there's actually a blog post on this that we have co-authored with our colleague Benjamin Lee, who is an expert in the job recommender at LinkedIn. That goes into a lot more detail about how exactly we take the recent activity of a user and process it into features.
Yeah. Can you put this in the show notes? The link?
Yeah.
Thanks.
Yeah, that'd be great. Yeah, and I have to say, I miss working with Ben. He was a great person to work with. Very, very sharp. That's awesome. So, that's a lot of great detail on sort of how he's working. I think something that's like maybe might be implicit, but I'm curious to dig into a little bit more detail. You talk about sort of taking the various like actions that somebody might take and somehow summarizing it into number, vector, etc. Is that particularly to deal with the sparseness of actions, or do you think that the action space is how useful is it to kind of like summarize it with an embedding vector versus just like counting how many times the action occurred? Like, what is the value that the embedding is bringing?
Yeah, so ideally, we would like to take an action as an actor, verb, and object tuple. For example, I applied for job X, or you applied for job Y. And then look at all these tuples of actor, verb, objects that have occurred in the past, say, 24 hours, and then try to use these as features somehow in a model. But using these directly in a model might not be that trivial. So typically, we would need to do some sort of summarization operation in order to condense this information into a few numbers so that it's easy for the model to learn the weight that needs to be assigned to the information that is encoded in these recent actions. Mm-hmm. So, and of course, vector representation is going to be better than a numeric representation just because more information can be encoded in a vector compared to a number.
So there is one thing that I think we should probably explain or parse out too, as we start to get into the idea of real time. Real time has a lot of different meanings for people. I've even heard some people say like real time or things like that. What exactly do you mean, Sasha, when you're talking about real time? What does that look like for you?
Right. So yeah, you're right. There's the real-time systems, and there's a real-time inference, and there's a lot of other things. So here, in particular, in this discussion, we're talking about real-time or near real-time generation of feature values. So what Rupesh was talking about when we are aggregating the events of the users that have done in the recent time, and do it in near real time. So near real time, approximately you can think about like seconds to minutes. That's the time range that of the events we're talking about. So this is usually happens in streaming systems somewhere. This is quite different from real-time inference, which talks about milliseconds, and that could be topic for different discussion. Or real-time systems like robotics and self-driving cars, definitely. So yeah, so we're talking about real-time features here. Near real-time feature generation.
Yeah, that's great. Yeah. Thanks for the clarification. Good call, Demetrius. One thing I'm curious about is from everything we've talked about, it sounds like there is a lot of complexity maybe into like actually supporting these kinds of real-time features. Just curious, like, are these always worth that effort? Are these always helpful?
So I am, of course, tempted to say yes. And in general, that is the answer to your question. But the reality is that we should consider adding these real-time features to only those recommender systems that are already well optimized. In other words, we should first focus on harvesting the low-hanging fruit, like optimizing the model structure or optimizing the set of batch computed features before we start considering adding these real-time features. And one thing that I would like to point out is just like any other feature in a model, not every single real-time feature is going to be useful. And since it can be non-trivial to add real-time features, we typically need to have some sort of a framework for deciding what real-time features to add. And from our experience at LinkedIn, we have seen that real-time versions of important batch computed features are usually useful. For instance, let's say that you have a recommender system that is currently leveraging batch computed features in the model for recommending jobs. And let's say that we already know that the average embedding of all the jobs that the user has applied to in the previous day is, let's say, the most or one of the most important features of the model. Then we should consider adding the real-time version of this feature, which would be the average embedding of all the jobs that the user has applied to in the current day or the current hour or the current minute as a feature. And also, by the way, I would like to mention that these real-time features should always complement the existing batch computed features. They should not replace them. For example, we can get the average embedding of all the jobs that the user applied to in the current day from our real-time feature pipeline. But we should still try to get the average embedding of all the jobs that the user applied to in the previous day through our batch pipeline.
Or previous month.
Yeah.
Yes.
I would love to unpack that a little bit. That's interesting. So like, can you just dive into like, why is that important? So if I know like, hey, these are the jobs I've been applying to today, why is it important for the models to understand these are the jobs you applied to over the last month?
So typically, like, we need to achieve a good balance between the long-term intent of the user and the short-term intent of the user. Jobs is probably not the right example, but let me talk about the content recommender. So let's say my long-term intent is to be more educated about AI. But in the short term, I might be more interested in knowing about, say, coronavirus or some vaccine for coronavirus. So in that case, the recommender systems need to know what my short-term intent is, which is gain information about coronavirus, but also balance that with my long-term intent of gaining more information about AI. So if the recommender system is able to differentiate my long-term intent and my short-term intent, then it's able to strike a balance between these two intents. And one way to identify my short-term and long-term intent and be able to differentiate or discriminate between these two is to have different sets of features that represent my short-term and long-term intents.
There's also this thing that users with more history, like power users, like Demetrius, right? So they could be there could be good information about their long-term intent, but for more fresh users, there's not such information. So all you have is like what they did right now, and then when they come here for the site to check it out, and just trying to see what's going on. If we are able to provide them useful information at that moment, that is very very important to keep them continue using the service.
Oh man, I got so many questions that I know will never make it through PR on the system that you use for content, but I'm going to ask them anyway. We hear stories, and I think one thing that I like to see on LinkedIn are stories of different companies that have made that transition. I think we mentioned before we started recording, Instacart put out an incredible blog post on how they did that. What, for you all, why is it that it is hard to do these real-time features?
Maybe we can go a little bit into history. So when I joined LinkedIn in 2020, few weeks before COVID, it was one of the things I want to work on, real-time features. So people mentioned that to me, and I looked into it, and it wasn't really clear what was the impact of that, and our ability to figure out the impact from that wasn't clear, and it was on the other hand, we had some examples of features working in this, and we knew that was hard. So basically, this like price performance or return on investment wasn't clear. But then we had a few conversations with Rupesh, and we found some interesting use cases that we wanted to look at, and it started looking more interesting, like the fact that we could work in this direction, and that's how we got going. So even then, it wasn't really clear, should we do it or shouldn't we do it, or should we go through this whole process of doing it. And then when we started, we did it in a kind of gradual manner. So we knew some things that were previously before. So there was SAMSA before. SAMSA is a streaming processor that was created at LinkedIn. 2015 maybe, maybe even before that, by the people who created Kafka, and there were some processors that people already did for real-time features, and they had some success. But on the other hand, it was really hard for machine learning engineers to run those processors, and we can go into more detail of that. But it was hard. So we tried to figure out a way, how do we kind of reach this balance between how hard is it and what's the impact, and we figured out one of the ways to do that via Pino. So Pino is yet another system developed at LinkedIn. That's a low latency analytics system. So basically, you collect events into some sort of a store, some sort of an index, and then there's a system that is able to aggregate those events and run certain queries on that, and produce that and give results. So, for example, when Dmitry is on the website looking for like views to his content or views to his profile, so there are graphs. So these graphs are powered by Pino, and there are real time. So meaning that there's real information that is behind, and this information is created on the fly. There's no like caching or pre compilation or something. So that system was there, and we looked into what is able, what we'll be able to do with this system, like what features we'll be able to do with the system. And we started with several use cases, and one of those use cases kind of went into production and had some results. That was job embeddings, right, Rupesh?
Yeah.
Yeah. That kind of gave the whole like the fact that there was there were results, there was business impact. That gave people confidence that we should continue going in this direction, and that's how we were able to continue in like a bigger effort that we call now. Yeah, internal name is FedEx Real Time, but I guess that would be called Feather Real Time right now. So we started this effort to create real time processors based on SAMSA. So that's yeah. But
sorry to interrupt. I'm going to sound really ignorant right now, but I had no idea A, Kafka came from LinkedIn, and B, Pinot came from LinkedIn, which are, we did a whole system design review on Pinterest and how they're using Pinot. And it's so cool to see that. It's just like mind blowing to hear about that. It's like I just found out that Santa Claus is real. And so, sorry, go ahead, Sasha. I cut you off, man. Keep going though.
No worries. So yeah, Kafka was created at LinkedIn, and Confluent was started by Jay Krebs and two other people from the Kafka team at LinkedIn. Yeah, that's a huge part of infrastructure everywhere. Pino is actually also they recently started a company. Kishore Krishna, who was working on it at LinkedIn, he started a company called Startree, and they're doing they're turning this into good business. So that's also a thing. So yeah, so hard. So we had some success with Pino-based solution. But it had some limitations as well. The limitations were mainly in the amount of like how much data you need to process in order to aggregate. So, for example, if you are interested in a particular member, actions of particular member, that would be maybe dozens or at most hundreds. I don't know. In your case, the measure is probably thousands, but and for most people, it's less. It is quite possible to kind of organize them, partition them in a way that access and aggregation of this data will be fast enough. However, if we are trying to do this for things like jobs or content, then the amount of events that we need to aggregate is much bigger. So it's thousands, tens of thousands, if not millions, right? In this case, Pino shows so we need to do something else, and for that we need to go back to like pre-computing idea. And pre-computing idea is you run SAMSA processor, which processes event as they come, and it knows for each event. For example, that's the event that Demetrius viewed this particular piece of content, right? So it looks at it and says, okay, what are the features that are impacted at this? So it has, in our situation, it has processors running for each one of those features. So they pick up this event and recompute this feature based on this new information, put this into the store, and the store is available for people for machine learning models to retrieve this information. So that's how the pre-computation works. So it has wider application, right? You can apply it in wider spectrum of uses. However, there's much more work you need to do upfront. You need to know exactly all these processors. You would say dozens, if not hundreds of processors for each feature, right? Do a lot of computation, and these processors, all of them are like a distributed systems with its own little problems. Some containers would fail, some hardware would fail, or other problems that happen with this system, and it is very non-trivial. Practically, we know that it's not trivial to support system like that. So you need a special kind of expertise of info people to be able to support and run this system. So it is really challenging for people like machine learning engineers to run this. So that was a big gap, and that's one of the answers to your question of why is it so hard. Part of the reason is that I'm a machine learning engineer. I don't care about your infra. Well, I do care, but I don't know that much about your infra, and I don't want to spend my time. My work is to make models. Why do you want me to respond to these on-call events in the middle of the night, right? So. So this is part of difficulty challenges that are there, and it took us significant time to figure out that A, we need to solve this challenge, and B, how to solve that. So we can go into more detail on that.
Awesome. Yeah, I think definitely great summary of a lot of the challenges of like building real-time features. And we kind of dug into this a little bit with Rupesh on, hey, are these always useful? Curious to hear about from your own experience, like what were the successes of adding real-time features? Maybe some of the examples of where they worked well.
So we have actually had pretty good success with real-time features in several of our recommender systems. And I'm going to share 3 examples here. So in our jobs recommender, we saw a 0.6% increase in job applies and a 20% reduction in dismisses of our job recommendations. And 20%, the 0.6 might seem like a small number, but it actually translates to a very large absolute number if you look at the total amount of job applications that happen on LinkedIn on a daily basis. In our field recommender, we saw a 0.3% increase in contributors. These are members who like, comment, share, or post in the field. And we also saw a 0.4% increase in revenue from sponsored updates in the feed. And lastly, in our search type ahead recommender, which recommends you autocomplete suggestions, we saw a 0.3% increase in click-through rate. But in general, we observed that the new and less active members benefited the most from these real-time features. And this was expected because these are the users for whom we have the least amount of historical activity data. So if I just signed up on LinkedIn and started taking some actions on LinkedIn, there is no historical data. So all that the recommender system can use is the activity that has been observed within this session to be able to personalize your recommendations within the session.
So in this type ahead example, Dimitri's brought in the beginning, we saw some improvements. Maybe not enough, but I guess we can work on more.
Dude, well, you got me to start posting more. I don't know if it was right around the 2020 period. It's funny because I was in sales, and at some point, LinkedIn became a way for me to get meetings. So I will say it like it is. I started spamming people on LinkedIn and tried to book meetings to get them to check out the tool that I was selling. But at some point, someone told me, they said, it's actually better if you just post stuff on LinkedIn and then people will come to you. And so that was a revelation. And I started doing that, and I've never looked back since. Luckily, I don't really have anything to sell now, so I can't spam people even if I wanted to. But going back into it and looking at this idea of these real-time features, and in this domain, are there any other learnings that you've had? Maybe, Sasha, there's something that you want to mention, with these experiences.
Yeah. So one thing I wanted to say, once again, we talked about it a little bit. Real-time features are kind of in terms of like a Maslow pyramid of needs, they are kind of up there. So Rupesh talked about this. Like, you need to get first basics right, like data flowing into the system, and the machine learning model working, and all that. So after that, when you at the point where you want to optimize things, that's where real-time features become very helpful, and they are very useful, but they come at a cost, and you need to definitely need to take this cost into account when you go for this development. So that's one thing. Another thing that I kind of noticed when we started working on this whole real time, there's this recurring theme of like how do we have this machine learning system, and there are many people who contribute to the system. So there are many hands in this pot, and how do we make it all work well without people in all this pot, with everybody kind of doing their part of the work. So this is really important. We mentioned about like machine learning engineers that care about their part of the thing, and then there are application engineers who care about their part of the thing, and there are infra engineers who care about their part of the thing, and they all together kind of tied together into this machine learning pipelines or inference pipelines. So this is a very kind of serious and interesting problem that you need to solve in implementing those machine learning systems. So in one little example that we were working on the real-time features, like a streaming processor for real-time features, and there was the maintenance problem or support maintenance problem that we're talking about. So our streaming team came up with this idea of a managed service. So they're building a managed service so that machine learning engineers can run their feature pipelines very, very easily, and it is managed by an infra team in the backend. So this kind of separation is very important. They also they talked about this in one of the meetups, so we can put this in show notes. But that's an interesting development, and in general separation. And lastly, I love machine learning as coming from software engineering background. I love machine learning because when you start working on it, it gets you out of your comfort zone very quickly. So basically, whatever are your assumptions, you will likely need to reconsider them. So, for example, at LinkedIn, LinkedIn is historically more leaned towards Java. So like all the applications are done in Java, and so we're essentially Java shop. What people say Java shop. But with the introduction of machine learning and the need to make a good environment for machine learning engineers, we were trying to make this environment make them more efficient in their environment. And then we absolutely need to use Python. So we get to two systems where machine learning engineers think they program in Python, but actually that translates to systems that run in Java. So whatever is the solution, we need to think about it. So that's one example of these challenges that happen in machine learning, and it's an amazing field. I'm really excited to work on it.
Yeah, I just want to add one small note. As a machine learning engineer, typically systems that are easy to use are well adopted. So, for instance, Sasha mentioned that there is always this separation of, or the boundaries between the work that an AI engineer has to do or an apps engineer, infra engineer has to do. Typically, if you ask an AI engineer or ML engineer to go into the infra domain and try to learn and make some changes there is some resistance. But if you make it very easy through, say, a config for them to get access to these real-time features, then the adoption rate is pretty high.
Yeah, that's definitely a great point. And it's cool to hear about all the challenges that were solved. It seems like if I find myself at LinkedIn in the future, I'll have much less frustration. But one of the things that you mentioned sort of offhand, Sasha, that I was very interested in. You talked a little bit about branching. LinkedIn is following a trunk-based development, and it sounds like there was some way that you ended up supporting like branching for machine learning. I would love to hear a little bit more about that.
Yeah, so that came from a conversation with another person you may know, Alex Patry. So he was
we had him on here.
Yeah. So he was really thinking about how to improve productivity of ML engineers. So what they were doing, given that we're working in trunk, they were making copies of the same kind of model code in different directories, all under the same trunk, and using that for experimentation. So different kind of variants of the model, and that had multiple problems. So we worked with our tools team and just talked to them, and it felt out of place. So it felt kind of a little bit hacky, this process. So we thought, can we do any better than that? And then the guys at the tools team thought about the way to use branching, use different branches. So what happens is that you have different experiments on the same model running as parallel branches, and you are actually able to deploy from different branches at the same time, and run this deployment as an experiment. And then when you are done experimenting, you see the model that works the best, and the winner you just kind of merge to the main trunk. So that is a very very interesting thing. I think it could be interesting. The topic for the conversation. I can get in touch with the people who do that. It's a very interesting development, and I think it deserves more people to know about this and think about applying this in their work.
All right, guys. So we've been talking about it a little bit. Real time is very popular. It's a hot topic these days. What are some things that you feel like do not get talked about enough when the discussion of real time comes up?
I would say the ease of use typically does not get discussed as much. As I mentioned earlier, as an AI engineer, I want to use a system that is easy to use. I don't, or rather, I would not prefer to work or leverage a system which has its own intricacies or complexities. So I think that is something which, as a community, we need to lay an emphasis on and make sure that whatever system we build is easy to use.
Sage advice.
Yeah, my personal pet peeve is portability. In particular, portability between streaming and batch. So when you define a feature and the same definition can work in streaming mode and in a batch mode. So if you don't have this, or regardless, actually, when you have batch feature, like features that you use in training, and features that you run in inference, you need to have a consistency between these two. Otherwise, what are you doing? Otherwise, your machine learning is actually not done right. So how do you achieve this portability is a big question. There are not yet like very good solutions to that. People are still working on this. There are some progress with that, but there's more to be done. So this problem that wasn't solved yet.
So tell me straight, Rupesh, does it matter if I put the link in the comments? Will more people see it if I put the link in the comments? That's all I want to know.
Maybe you should schedule a coffee chat with the CEO of LinkedIn.
No, he's a power user too.
Yeah. This has been great, guys. Thank you so much for coming on here and talking to us about this. Like we mentioned a few times, this is such a hot topic, and it's so cool to see how you all have gone through the transition, and I appreciate you sharing that with us.
Thank you for having us.